Hello, everyone, and welcome to our 30th Claris Community Live. It's my pleasure today to welcome Mark Richmond and Greg Lane from Skeleton Key. And today we're going to talk about foundations of improving app performance. So as we get started, as always, please click on the apps button down in the lower right and take our poll. Just tell us a little bit more about your experience and your current deployment environment. That will help Mark and Greg pitch their conversation more effectively for you. And with that, Mark and Greg, why don't you introduce yourselves?
So I'm Mark Richmond. I'm the founder and CEO of Skeleton Key. We're a platinum partner based out of St. Louis with team members scattered across the US. And as you'll hear soon, I've been talking about this topic since 2010, and it kind of ties into my background, but I'll cover that in a little bit. Greg?
I'm Greg Lane. I've been a FileMaker user since 1986. I'm coming up on 40 years, which is exciting for me. I've been with Skeleton Key since 2007, so almost 18 years now. And I've been a developer, had a number of different roles here. I think my current title is CTO.
Wow, Greg, I think you're one of the few people I've met who's possibly been using FileMaker longer than I have, because I started my freshman year in college a few years after you.
I think I was right there too, around 88, 89.
Yep.
I don't develop like Greg is a big part of our engineering team, and we call him our Claris champion. Like he's our highest escalation resource because of the depth of his experience and involvement in sort of the cutting edge of what Claris is doing. I personally don't develop very often anymore, but fortunately today's topic is very fundamental, and that's very much in my wheelhouse.
Oh, okay. And it looks like I'm looking at my questions and I somehow managed to break one of them. So our question about how are your apps deployed? I managed to break that question, but it looks like the majority are local server with mix of local and remote users because I somehow took away the cloud option when I set up the poll. And our next question was, what is the age of your FileMaker apps that you support? And I gave people the option to select all that apply. And it looks like about 60% are in the 11 to 25-year-old range, and 40% are supporting apps in the 5 to 10-year range. A small fraction, 26 years plus, and about a third have apps that are less than 5 years old. So it sounds like a good distribution, but also weighted toward those older apps. And then I'm going to actually show the word cloud. So how many people use your apps at the same time? It's a big distribution from, it looks like 7 or a handful to over 4,000. But it looks like the sweet spot is in the like 10 to 50 range is where the bulk of the answers are. And for our last question, how do you feel that your apps perform right now? 70% said sometimes slow, 20% say it's great, and 9% users complain about performance all the time. So with that, I will let you all get started.
All right. And none of that's too surprising. I think I'd probably put myself in a similar boat. While we have some newer apps, we definitely have apps with clients that are in that 11 to 25-year range. Right? Our company's 22 years old, and so we have clients who've been working with us since the beginning, and many over the years who've come along and are somewhere in that mix as well. And then the newest ones, of course, hopefully we're doing a much better job than we did back then, keeping performance in mind. And I think it's sometimes slow. It's even something we encounter with our own internal solutions. I was just talking with Jay, who's our head of engineering, and he was talking about it continues to be something we have to be mindful of, even with the seasoned developers we have on our team, is some of these basic things we're going to talk about today are still really important. So let me share my slide and set some foundational stuff we're going to talk about here. So first and foremost, this is going to be, you're going to see a subset of some of the slides that I used in my recent Engage presentation at the last Claris Engage. I know that Rosemary's going to share a link to that recording if you want to see the whole thing. What you won't get in that, of course, is Greg's perspective, which I've asked him to join us because it's kind of his fault that we're even talking about this topic. Back in 2009, shortly after he joined the team, he went to San Francisco and I didn't, and saw that first under the hood session with John Thatcher, who was an engineer on the server team, I think at Claris at the time. And I was more of a IT person back then. I did some development, but I also had a foot in the IT space and the networking space and the security space. That was something our company used to do as well. And both Greg and another member of my team was like, you have to see this presentation. You have to see this slide deck. And maybe consider presenting and talking about it. And that's what led to the first of what turned out to be a series of articles over time, a series of presentations. And I'm just showing you a tiny set of them here. There are probably a couple dozen presentations that have been done by members of the community, various folks on the engineering teams at Claris over the years, talking about either the whole topic of performance or very specific elements of it. And I know Rosemary's got some of that information that she'll be sharing. And then I've dug up from my archives some of the materials I created and some of the white papers I helped write, and even some of that information is out of date. I think we'll identify that a lot of it's actually still current, and a lot of it's fundamental and foundational. And so that's the goal today. We're going to cover core concepts. We're going to cover straightforward techniques and really the simplest things you could do to get a lot of benefit. What we're not going to talk about are theories, edge cases, arcane, exotic examples of edge performance, debates about specific calculations maybe, or debates about JavaScript in the web viewer, or server tuning and performance and statistics. That's all really important stuff and can be really useful. But there's a whole bunch of simpler things you can do first, from the very beginning of planning your solutions to actually implementing them. And when we encounter a solution that's underperforming, there's some things we just look for right away, like quick diagnosis, like, does it hurt here? Is this going on there? Because even if those other more deeper opportunities exist to make things better, all too often, even very seasoned developers, even folks like us, will find that something has crept in our solution in a way that has started to create performance drains, stuff we couldn't predict or maybe didn't predict when we were designing and building and deploying it when it was a brand new solution. And while those aren't always easy to fix after the fact, my goal today is to arm you with the knowledge and then hopefully collectively give you a sense of how maybe the next application you build can be built a bit smarter from the very beginning. So as time permits, maybe we'll get into some of these things, but we're really going to try to keep this like fundamentals, ABCs kind of thing, and hopefully help a lot of you make a lot of impact. So before we do, I don't know if there's any questions about what we're going to cover that you think we should tackle, or should we just keep going, Rosemary?
We can keep going, but I think an observation from William in the chat leads right into what you're going to start with. He says, communication with remote servers via the internet is probably a major cause of slowness.
It is. In fact, I think it's the first slide in, or the first topic in the behaviors that we want you to understand. So you can think of this as sort of almost like the laws of thermodynamics, right? Or the fundamental laws of the universe, like understanding some of these basic concepts that we're going to cover and stop along the way to give it a chance to talk a little bit more deeply about each grouping. I think we're going to cover 2 or 3 at a time. Will provide an opportunity for us to understand, but they're kind of stacked in an order that I think maybe was about the level of impact they could have. And each of them is going to have pitfalls where we could go down a rabbit hole easily and debate and discuss things. But the first one in particular, latency, I'm going to definitely lean on Greg a bit, because this is probably the most technical of all the topics we would cover, but it's a fundamental concept to understand. And it's one that's really hard to understand if you don't think the way networks work. As someone who had a networking background, and Greg, who a computer science background, it was part of the education. But if you're coming in like a citizen developer or a creative, or a lot of the people in our community are, you're not thinking about packets and routers and endpoints and anything related to network other than, do you have a gigabit? Like, how much bandwidth do you have? The concept of latency almost never comes up. So let's dive in. So latency is a geeky term for how slow things are. And the way I like to think about it is, like a traffic, that there's a fast lane, there's a slow lane, and there can be various factors like how many cars are on the highway at a time that even make the fast lane slow. Technically, it's the measure of time it takes for information to travel over a network between 2 points and how long it takes to make that transit from one end to the other. Generally, high latency is bad and low latency is good. And the biggest factors that generally influence it are distance and congestion. There can be things about like how much bandwidth is there or how big the data you're sending, but those are more contributing factors, like in terms of a ceiling or in terms of how badly you feel the latency, because you're sending a lot of data, so you really feel it as you send it. The best way to illustrate it, I think, would be some screenshots that Greg provided. And actually, this is from Greg's 2019 presentation on network performance, because I think you had a slightly better definition here. Anything you want to chime in before we look at some of the screenshots, Greg, in terms of the definitions that I missed, or you'd want to offer a different perspective?
No, I think the screenshots will help. But I guess I would say that understanding the latency for both you and your users is between the workstation or client or device that they're using and the server is really important. And it can change over time. If they're working from home and their teenager suddenly starts downloading a 100 GB game, it may crush the both the bandwidth and the latency may shoot up while those kinds of activities are happening. So you need to measure this periodically and understand what the latency is like for your users to understand how your app's going to perform.
Yeah, that's a great example. I have several teenage boys, and during COVID in particular, they were all at home. So I went to the office because there was, despite having 2 internet lines at home, there was no bandwidth. And even when there was bandwidth, anyone who was doing anything was competing for the bandwidth, and therefore I had to wait longer for the same traffic that might have moved fine at 10 o'clock at night when they were in bed. So um, one thing else you said there that reminded me, and then we'll talk a little bit about this screenshot you provided, but I think that idea that it changes over time, it can be critical to recognize that even a line, let's say someone's working from home and they regularly have a certain degree of latency, but that other factors outside your home could affect that as well, or outside your remote office. It could be that you're part of the type of internet connection that you have from that location, that neighborhood is a shared one. Some things like cable are shared, and maybe someone else in the nearby house is doing something. There's these things, networks, have various hubs that they come into, where lots of bandwidth is pooled and then put into larger pipes going elsewhere. And so it could be something on the general network, like an accident 10 miles away that's causing a backup where you are on your side road. And so it isn't always directly under your control. Even if you feel like you've regularly had pretty reliable performance, you could have some conditions like your kid downloading something or something completely outside your control, like get off your console, that could affect it. Can you talk a little bit about this table and what we use it for at Skeleton Key?
Yeah, so this is a session table that we put into most of the solutions that we build. And basically, we create one record for every user when they log into the solution. And we're capturing various information about that user, their connection, what version of FileMaker they're using, screen sizes and things like that. One of the things we've been capturing for a while now is latency. And so we measure the latency for that connection at the time they connect to the database. And you'll see a big range here. This particular server is hosted at a major data center in Chicago, and the users who are connecting here run from Colorado to North Carolina, I think, and up into New York and various places. So the people who are closest in St. Louis or Chicago, they're those lowest numbers, the single digit 8.9, 9.5, things like that. People who are further away, you'll see the 50s and 60s. And there's a big difference between those when you talk about round trip of lots of traffic and lots of remote calls going back and forth between pro and server. And so that, 5 times slower, if you think of it that way, things can really add up there. The last line on this table is a web direct connection. So that's half a second. And this is between, the web publishing engine and the database server. So there's additional latency that happens between the web browser and WebDirect, but it's kind of different because the things that when you're running scripts and creating records and things like that, that's really happening between WebDirect and the database server. And it is less impacted by the latency from the client itself. And so that's why sometimes some applications perform really, really well over WebDirect. So it's another thing to think about.
Yeah.
And I think you meant half a millisecond, right? Not half a second. That's 0.5
Yes. Yeah, thank you.
milliseconds, right? So that's
Yes.
100 times faster than any of the 50s we see there, which means even for the most optimized exchange of information between the server, let's say you both open and load a single screen with a single record, you're going to have one that has, in milliseconds, granted, it might be 50 milliseconds versus 0.5, but you can think of that almost like, in my brain, it's like there's a whole bunch of box cars filled with stuff on a train, and then we've got something at the beginning of the end, which is the penalty or the fee you pay to bring that train through. Is that a 0.5 or a 10 millisecond penalty, or is it a 50 millisecond penalty that, in terms of how long it's going to take for this whole train to move there and back? You assume, let's say you have 100 packets worth of data and you're moving that, you're going to have that penalty for each of those packets. And if it's a round trip, like Greg said, where you have to send information to the server, then get information back, or vice versa, the more data you're moving, the more you're going to feel that. So this is a really fundamental idea, just in terms of how slow is the connection, not how big is the pipe. And matching it over time allows us to go find for a particular user. Like we can go find all Mark's records, or if we have a user, let's say in North Carolina, find all of their records and see if they have a pretty consistent, or if they're having a highly erratic experience. And it also helps us sleuth out things like, it normally works really well, but it's not working well today. And then you can see that they have a dramatically different number, and maybe they're coming from, a different location than normal. They're at a coffee shop, or it's a weekend and all their kids are home playing or something. And it gives you some data that's immediately accessible in your FileMaker solution that you can use for some of that troubleshooting without having to know server or know any kind of networking tools.
And there's a burning question from several people all at once. How are you measuring latency? Or what FileMaker calculation or technique are you using to do that?
Great question. Greg, would you speak to this, please, since this is your calculation?
So there are probably lots of ways to do this. This is a technique that I've been using for several years. A simple while function. We're testing something that we know takes one remote call to the server, and that's the get user count function. So that's the crux of this, is we're calling the get user count function, in this case 10 times, and taking an average of those. You can measure it just once if your latency is pretty steady and reliable, but 10 gives you a good average. You could use, if you've got very low latency and you want a more accurate number, you could do more iterations. But the gist of it is you're counting how long it takes to get a response to this question, get user count. And that always comes from the server. It always takes one remote call.
And I should mention a couple of things. I asked some questions about this for Greg. If any of you know networking from the past and they've ever used the ping function, P-I-N-G, to ping an IP address to test if a connection works, that's kind of an equivalent, I think. But the ping, I think, runs 6 or 8 times by default when you run it. I forget the setting on some operating systems. And each of them tells you how long, what the milliseconds is. And so you can kind of quickly scan as a human and see, okay, that's pretty consistent, or wow, there's some wide variability there. What's going on? Is there something maybe creating periodic congestion? I asked about the get user count because there's lots of get functions that you would think you would get always calculated one time on the fly dynamically with the reliable. And I think Greg indicated that he tried lots of different ones and found that some of them seem to be cached. Some of them seem to not trigger a remote call, a single remote call. Some of them require none, surprisingly, or perhaps more than one. And so he was really looking for one that was precise, and this has been pretty consistently reliable for that. Other latency questions while we're on latency before we go to the next one? I know we've got a Q&A section between these sections, so I'll just keep going. All right.
Yeah, keep going.
Yeah, you can use tools. There's all kinds of technology out there. We'll talk about tools maybe at the end and answer questions, but you could put JMeter, and you could, throw up Wireshark, and you could throw all kinds of things if you wanted to do this, but doing it in the solution makes it immediately accessible to any developer. And that's, again, a fundamental idea we're focusing on here, is what can you do as a developer without having to necessarily knock on the IT door or escalate to your server person. You may be both, but I'm assuming a lot of people here are developers and not necessarily server aficionados. Schema. This is probably the most radioactive topic we could talk about in this because people are very passionate about their schema. So I'm going to make some general comments here, and then we'll field the questions and see how we can keep it from burning anybody. There's two things to think about when it comes to your schema, and that is the data model, right? Forget FileMaker for a second. What are the tables and the relationships between them that fundamentally let your data model work? Don't think about lines and joins and connections. Think about this is an entity company, this is another entity contacts, and here are the primary keys and foreign keys that connect them to each other. That is true in any database system, and there's a lot of different ways you can approach data modeling. And we're going to talk about some of the things you can do to maybe leverage data modeling techniques to address performance issues, versus just have things all be in simple, data models where sometimes they won't perform as well because of other fundamental behaviors of FileMaker. The relationship graph is how you've chosen to express that data model and create joins that are a bit permanent, right? Even if they have variable predicates or globals or other kinds of things, it's how you've decided to express and visualize that the relationship between those different entities, and how you've chosen effectively to hardwire them in various combinations with various table occurrences. The data model, the fundamental concept, the relationship graph, is a convoluted, your personal approach. Some people like to do a graph that's all connected to each other. Others like to do an anchor buoy or another kind of approach that makes it easier for them to navigate various pop-up menus as they're doing development and understand the context they're in, really related to other things. Neither is necessarily better or worse than the other, because there's a lot of benefits to come from being comfortable with your relationship graph for the purposes of development and troubleshooting. But they're not the same thing. So I want to make sure we're focusing on data model and not relationship graph. But there are a couple of things I will say, this is where I'm going to get a little radioactive, about the relationship graph. Because you can do things there that make things worse. How much worse is hard to say. And conversations about this, even with engineers, is always it depends. So talking to Claris people, they themselves won't throw down a gauntlet on either side of this fence. What we can say is that relationships in FileMaker, since FileMaker 7, are bidirectional by default, right? So a company, let's say a parent to a child, a parent can have many kids, and that child record would have only one parent, right? So usually a contact belongs to one company, and a company can have many contacts. I know there's exceptions to that, right? I have 4 kids and they have 2 parents, et cetera, but we're not being literal, we're thinking data model now. So anytime we create 2 relationships, like we had to way back when in FileMaker 6 and before, to represent what is really represented by just a pair related to each other, we are creating additional structure in our solution. You could argue, with all the commands we have at our fingertips now as developers, you could even have a relationship graph with no relationships permanently associated between items. You could do all those joins dynamically on the fly with execute SQL and other kinds of commands, but that's an extreme version of that convoluted relationship graph. But the main point I want to say is that you get bidirectional by design in how the platform is built, and there are really good opportunities to leverage it and keep your relationship graph simpler. And I know there's trade-offs to that in terms of complexity of your graph or navigation through your graph when you're developing, but it is something where you get a 2 for 1, buy one, get one kind of thing. And you shouldn't just dismiss it out of hand, but understand how it might be useful to you at times. Another thing we know is true is that the more that you have on your relationship graph, the more objects you have in your relationship graph, the more relationships you have in your relationship graph between those objects, and the more occurrences you have in any one table, the more dependencies that exist in that table for Claris, the platform, to resolve when things change. So if I change a value that somehow is expressed in many different table occurrences and potentially is involved in many different relationships in that graph, the dependency tree, whatever is going to be necessary in terms of updating all those joins, is going to potentially not just be an isolated experience, it's going to be a widespread experience, right? So it's not going to be contained to just a simple join between 2 objects. It might be here and here and here and here and here. And so again, another argument for a simpler relationship graph is not only closer to being what your real data model is, but it also reduces the complexity of the graph. And so you're not adding all those dependencies into the mix. And then the last is that you don't have to use the relationship graph to get a subset of data or a related set of data. there are a lot of other powerful features in the Claris platform to go to related records and constrain a found set, and to use execute SQL to identify a set of records and or the data API to bring you into a found set of records without having to necessarily build a unique set of table occurrences for every one of those instances, or very arcane, complicated relationship predicate models to do that as well. So again, simple can be often better, and more importantly, simple can often be faster. But that's not me saying you should do all unified graphs and your data model and your relationship graphs to somehow coalesce into one. There's a lot of value in having, in certain situations, groups of tables connected together for very particular use cases. But the goal is, I think, to really ask yourself, do I need this, or is it just convenient because I can, right? There's nothing about platform that keeps us from doing what we want usually, but we can shoot ourselves in the foot in the process. I think I have a few images about this, but I want to pause because I probably lit a few fires there with that discussion.
Nothing in chat on
Nothing.
this.
Wow.
Nothing.
All right. Well, great. We're going to keep going. And we're going to cover some of these, I think, when we get to records, because we're going to have some relationship graph drawings here. Remember what I said about relationship graphs and data model, because I think that's going to come up when we start talking about records. Anything you would add, Greg, to that whole thing about relationships? Because you built a lot of solutions a lot of different ways, I'm sure.
No, I think you covered it well. I think that one of the approaches that we tend to take in a lot of solutions is to do less with the relationship graph and do more through scripting and other techniques. Keep it simple. I know that's a theme we're going to hit on a lot. Is try to keep things simple. The relationship graph can get really, really heavy and impose a lot of overhead throughout all that you're doing inside of FileMaker. So keep it simple.
Right. One thing I love that about that comment is, I've had developers on our team who've come from different ideologies around relationship graphs before, and have made the argument that their approach to the graph really made it easy for them to understand where they were when they were scripting, what the context of a calculation or a script was, and therefore how to identify and jump to or navigate through the relationship model. And it was very organized, and it worked really well for them and accelerated their development. The flip side was every time they made a change to their data model, they had a whole bunch of places they had to make updates inside the relationship graph to maintain that order that helped them with development. And so it started out really nice. And this will be another thing we talk about, how things start out when you're building a solution versus how things eventually evolve to become in your solution. Greg made a really great point we'll cover later, just about thinking about that future. And those of you who have solutions 11 to 25 years old, your solution was likely a very different animal in terms of complexity and scale and importance to the business when you first built it than it is now. And as a result, the things that weren't problems then, or you might not have been able to predict now, you can see in retrospect, wow, had I only known, what can I use and learn from that to apply to the future?
Yeah, there's a great question about that evolution, and that is, are there any tools available to help economize and clean up the relationship graph?
Oh, wow. That's a great question. I don't know if I have a great answer. Think of any, Greg?
Certainly, there were other suggestions in the chat about using Inspector Pro, tools like base elements, FM perception, things like that can all be helpful to understand the structure of your database. And but I don't know of any automated things. Look for things that are not used is really important, and some of those tools will help you identify those things that are they're in your solution but they're really not used. So
Yeah. I think what
Mark?
popped in my head. Sorry, go on.
Oh, I was just gonna say, there's another question.
Yeah, sure.
So you suggest we should use less anchor buoy than we do?
No, I think it's really important that the developer is comfortable in the environment to be an effective developer. But I think to combine that question with, and I should say, we don't use a lot of it at Skeleton Key, right? Just to be completely candid and open about it. But we use elements of it. We may have our primary relationship graph for a solution may be initially more of a unified graph or a spider graph, whatever terminology you prefer, where we take advantage of those bidirectional relationships, and we try to keep it simple and use some of those other techniques, like Greg said, to I think maybe use the highways to get to records, and then use scripts to narrow sets and sorts and filters and things, because of the buy one get 10, right? If I can use one primary pathway to go to related records and use scripts to get an abundance of different permutations of the results, that might be significantly less expensive for me to develop and maintain, and more performant than if I had a whole bunch of complete complex table occurrence with every one of those different filters, joins, and sorts that I might need. So that's our approach. But there are certainly situations where, because of a reporting requirement, because of a workflow requirement, we will create a little anchor buoy setup for a particular scenario. So we often end up with what I would call hybrid solutions, not strictly one side or the other side of the equation, but finding the best mix of the two that works for your solution. To speak to what Greg said and kind of connect those dots, I know over the past I've seen people who would take that idea of an anchor buoy model, and they would build it all out, right? They would say, okay, well, I've got these 5 primary tables, so I'm going to build each of my anchor buoy setups from the perspective of each of them, and then discover, maybe using inspector or base elements or a tool, that they're not using one of those much, because the way that the workflow, the way that the layouts were built, the way that the users actually use the system most efficiently didn't require the use of something they had built. And so they had built unnecessary structure in the relationship graph that they really didn't visit. It's kind of like building a guest room and never inviting anyone to stay over. So I think, no, absolutely not saying don't use any one method or the other, but try to at least open your mind to the benefits the alternate model might offer, and find some middle ground where you can leverage both. And probably my only flag I'll plant in the sand would be that I'm a firm believer, and I got some sense of this true from back in the day when I started planting this flag from some engineers at Claris, that bidirectionality is a gift. Let's not squander that gift. And some of these techniques ignore that gift entirely in exchange for some other kind of theory of approach and style. And I think that's disappointing, like for the engineers in particular. Like, we built this great thing and got you to a relational model, enjoy it, and then some people went a different direction and decided to ignore it. So I'd say find a middle ground. All right, gonna keep going.
Yep.
All right, we're gonna have plenty of time Q&A at the end. We can revisit any of these topics. This is another really important topic, and it's going to get a little bit into the concepts of latency and a little bit into the concepts of schema, and that is to understand how records are structured in Claris. You think of fields as individual, properties of a record, but as far as Claris is concerned, essentially a record is a thing, and the fields are just elements of it. They don't really move very independently for the most part. There's exceptions, we'll talk about them, but you need to think of it like a train car. Each of those cars represents a unique data field in that table, and when you ask for that record, even if your screen is only showing a couple of those fields, you get the whole train. And that's really important, because it can lead to some serious questions about how your users will use the data, and how you might want to update your data model so that you're not necessarily moving trains all over the place. If you've ever been to a train yard, it is not a graceful place, right? To move one record or one train from one place to another requires a whole lot of effort. And the same would be true if you go into a form view and look at a record, and you're getting not just that record, but potentially you're getting maybe even 25 records, 25 trains worth of data, because that's one of the ways that Claris will stream and buffer the data to give it to you. So if you flip to the next record, it's really smooth. So this isn't just a single record problem. It actually is a combination of big records bundled up together into sets of records that move to your client to help things feel faster and be cached, but you pay for some of that penalty when they move in the beginning. So think bundles of fields generally. Understand your records are a thing and they move together in concert, kind of like a bunch of people with their arms locked together. If you've ever done that, it's not a very graceful thing. And think about the fact that when you get one record and you aren't necessarily managing your found set, you might actually be getting lots of other records around it that you have no intention of using, right? You might be in a list view with all the records that are showing up by default, and you don't intend to look at any of them. The very first action you're going to do is do a find for open invoices. Well, you've just looked at a whole bunch of old invoices, and all that data moved to your client over whatever latency you have, before you do your find and find the ones you really wish you had.
Yeah.
Or you go into, yeah.
I just want to share something that came up in the chat way earlier when we were first talking about kind of pain points. Giandrea said, what drives me crazy is the find message for something that pops up on a client and nobody knows what's going on. So you get that little message, you like load it, go to a layout, you get that little message that says find in progress or whatever
Yes.
it is.
There could be several different reasons for that, and I can think of some, and they may not be the most common ones. Greg, do you have a diagnosis of what's going on there?
Usually, if I understand the question correctly, it would be because a portal or some relationship is being evaluated, and we're having to get all of this related data that's associated with the records on the current screen or the current found set for the current context. So it's probably due to relationships and things coming from other contexts.
Yeah, I see it a lot if you're displaying, for example, a summary field or just you're not even showing a portal, but you're showing a calculation that's aggregating a bunch of related records. So FileMaker has to get that data before it can evaluate that unstored calculation.
Right. I'm going to just remind us, like, we're going to share a bunch of the old content, and that means going all the way back to 2009. And in some of those articles and some of those presentations and some of those videos even, you're going to have a deeper dive into some of the things that can cause that kind of what I call an avalanche of data that you don't even understand what's happening. Sometimes it can just be poorly coded, like you've got a conditional format that's referencing something and is trying to figure out how to resolve it, and it turns out it was copied and pasted from another object, and it can't resolve that calculation. More often, it's something like a script trigger that's doing a find against an unstored calculation, or it's a portal that's got some kind of filter or predicate, and right now the server's too busy to do that work for you, so the client's going to get all the data and do the work. Even Claris's efforts over the years to get the server to do some of the more complex lifting for us and send us just the result we need is always balanced by what else the server is doing. And you can't say, evaluate this on the server for me before you make the client do it. Sometimes sorts happen locally. Sometimes summaries and filtering happens locally anyway. And again, if you have low latency, you're really going to feel that. And the end result might be no benefit to you, right? So we're going to talk about summary fields. We're going to talk about unstored calcs. We're going to cover all these things as well. So not only do they move bundles, not only do we get batches of bundles to buffer and allow the solution to feel smoother as we scroll through or flip through records, but any change to the bundle ships the whole bundle. So that means if I get one of these trains into the station and I open up one door and I take one object out and I put one object in, just that one car, that information goes back to the server. And of course, I already have it. That's fine. It doesn't affect me. I've got that data. It sends the changes to the server. We're going to talk about the fact that everybody else who had skin in that game, everybody else who was showing that record maybe on their screen right now, they're going to get the updated bundle. And so we could potentially trigger some impact on other users because we're editing something that they also happen to be looking at the same time. So again, managing what people get, what they see, and what they use is a really effective way, not just to help you, but your neighbor as well.
Yeah, there's a question about prefetching. So
Yeah, sure.
just how many records does FileMaker prefetch? And does that also apply to related records for portals?
So if we just forget for a second anything, I'm going to answer just from a simple standpoint. My belief and understanding right now is, and I can confirm this, but I think the last time I talked about this with Clay, it was true still, that that form view prefetches 25 records at a time. Now that could be overturned by a summary field that's summarizing the whole found set, but let's just say the most vanilla solution you can imagine: no summaries, unstored calculations, or predicate filtering on portals, no portals, just a simple single table, basic data. You go into form view, you're in a found set that's bigger than 25 records. It's going to prefetch 25 records. So, because it thinks the next thing you're going to do potentially is go to the next record, or move in that found set. In a list view, it's going to prefetch the records you can see. So depending on how tall your monitor is and, how many records actually display, again, up to the size of your screen. And again, assuming no summary fields or anything else that overrides that and peeks into the data that you can't see. Portals are the same way. If you have a portal, it's going to look to the rows it can see and show you those and read those. The real thing that happens isn't those. Those basic parameters are pretty efficient. There could be reasons why they're not. This is going to be an example of it when we look at this screenshot together. But it's when you have these sorts and filters and summaries and unstored calculations that operate on other records you can't see, other records beyond the 25 in the form view, that you start to get more than you wanted in terms of the data. And so those are really more often the culprits about prefetching. It's not prefetching. You are now going above and beyond to fetch records for some other purpose unrelated to prefetching. But prefetching itself is fairly innocuous, except when you have wide tables. So think of a train that's got 10 cars. That's probably relatively nimble compared to a train that has 227 cars or 62 cars. One of the first things I will do to this day when I encounter a new solution is go right to the table list and look at how wide the tables are. And I don't even pay attention initially. I think there's only one record in that 227 field table. It's probably some kind of table with graphics or settings or something. I don't know what it is, but it's going to get my attention because that's really wide. And even when I see tables with 60, or 50 fields, I start to wonder, is that necessary in the data model? Is there an entity that's that complex? Or do we have potentially a solution that was built at a time when someone didn't understand relational models, and so they built instances of a field to store multiple phone numbers, or they had instances of a field to store grades or record information over time. And it's just another year or two till they add 10 more instances of that field and that table gets wider. You have anything you want to say about that? Because I know this is your screenshot, but I think we both do that. We both look and see how wide the tables are right off the bat.
Yeah, the number of fields in the table is really important, and you look for those tables that have hundreds of thousands of records or millions of records or things like that, and that's an obvious point you want to look at. And hopefully those don't line up. You don't want 100 fields in a table that's got a million records. That's a real sign of a problem.
I didn't, for some reason, put an arrow pointing to the 79 fields, but I probably should have done. So that 227 gets my attention. Anything 50 and above generally gets my attention. It's my own rule of thumb. And there could be good reasons. It could be that there's only 10 or 15 fields there of data, and then there's some summary fields and some unstored calcs. And as long as those are being managed carefully, and we'll talk about fields in a second, and only shown and triggered and invoked, whatever word you prefer, leveraged in some way when you need them, then you might have some service fields that are not really storing data. They're storing some logic or some intelligence. And so, okay, I might go into one of those tables and say, okay, text number, date, timestamp. Okay, those are the actual payload. The rest of these are doing other things. Let's make sure next round when we're looking for performance, where are those other fields maybe being called into action? Because those are the ones that exceed the prefetch. Those are the ones that might look to other records that are related or larger than the set of records I intended to be working with. So these are some examples of diagrams I grabbed from a presentation I did a long time ago, talking about the benefits of understanding a one-to-one relationship in a data model. So completely out of context, but I just wanted to share this to kind of plant some seeds. What do you do if you have a wide table and you don't really know how to split it? Because there's not a one-to-many. Like you're like, well, it's my database manages manuscripts or catalogs. And so I've got, a few fields that are really regular, kind of like date, author, number of pages. But then I've got this really big text block of data. Or maybe you have a product table and it's got a bunch of fields describing the product, but then it has a couple of fields that are related to inventory and how many are on hand and how many are allocated and how many have been sold. And every time there's a transaction, that record is being updated. And because we know from what we talked about before, every change to these records changes the whole record. And even if one field changes, and affects everybody who's using that record. And because the whole record travels as a bundle. So one way to think about this, and these are 4 examples that we talked about in that presentation. I think Jonathan Thatcher covered this in one of his sessions as well, was 4 different scenarios where you might think about splitting a table from one table into 2. And yeah, that adds some complexity to your data model, but can have a really important benefit. So one way to think about it is just field sets, primary data versus secondary data. what is the data most people need most of the time, and what is the data that only some people use some of the time because it's on the third tab on your interface, or it's on a slide panel that almost no one ever clicks to, but it is part of that record. Putting it into a separate table allows it to be there when it's needed, but only sent to the user when they look at it. So it's treating like two parts as separate, even though you think of them as a whole. We've separated them on purpose so that we can meet them out to the user on demand in chunks. Going down to the left, list fields versus form fields. This is a pretty simple approach. If you think, again, thinking ahead, planning for your solution, hey, I've got a list field that is very busy, lots of sorting, lots of searching, lots of summarizing. But then I've got a whole bunch of data about that record that I don't necessarily need until I find the record I want, and then I go look at it. Well, then you might decide to put your list fields in a table and put your form fields in another table. You can still bring a list field over to the form field if you need to show it on the same screen. You don't need to duplicate your fields, but it allows you to navigate and work inside the list field without all that extra payload that comes with those form fields. Third option and fourth option are just two different versions of the same idea. This idea of isolating a heavy field or a busy field from the other fields. So in the product table example, in the bottom right, I might have a bunch of product values that almost never change. The product description, the SKU, things like that that are kind of set and never really modified, but they're searched and used for that kind of work. But then I've got the inventory fields. Those are really busy. And you could put all those in a busy field table, product inventory numbers, or you might say, well, yeah, but one of them's changing a lot for transactions. The other one's changing a lot for receiving. And I don't want selling and receiving to keep bugging each other with data uploads. You might decide to put, receiving numbers in one and sold numbers in the other, so that all that transaction activity is just really nimble and really fast. It's only affecting one. You could literally have a table with a foreign key, a primary key, and a number. You might have some other metadata fields about it, but it would be a really lightweight table that could change all the time and have almost no impact on anybody else and almost never get locked. And so, because it's so quick, that the opportunity for record locking goes down. Because you're not going to contend with someone else maybe who's selling or receiving that same product elsewhere at the same time. Same with the heavy fields. That's the example of a large contract. Maybe you put the big text field in a separate table so that when you flip to form view or open up that screen or that card window to look at it, then it loads just that one, related record, and not necessarily prefetch 25 of those records, 25 of those large payloads. So these are all schema approaches to splitting wide tables into smaller tables for a variety of performance reasons.
Yeah, so there's a question, and I just want to have you clarify this. So going back to just generally wide tables, question is does this mean it's better to have telephone 1, telephone 2, telephone 3 fields in the same table rather than breaking them into their own related table? Or would you go
the
the
other
other
way?
way?
Related table, the real benefits of relational tables, I think, is when you might have many, and maybe even an indeterminate number. It's having, if you just know you're going to have 3 spots and that's all you're going to have, there may be an insignificant penalty to have those in your main table with your contact. So it's going to depend on your particular model. Some companies put all their different addresses in one table because there's a whole variety and they want an unlimited number, and then they have some way to categorize them. So there's no right or wrong way, but simple is often better. And yes, you have to balance simple versus wide, right? Is it better to have a little complexity so that things aren't as wide, depending on how I use the contact data versus how I use those phone numbers? Or would it be better just have them together because my model is simpler and it's just a text field with some phone numbers in it? Happy to look at that and see whether or not, the key thing is that causing a problem or not? And there's various ways you can test for that. I know we're running long on time, so I'm going to go a little faster and keep moving.
Yeah, I'm
Any
just
point
going
on
to
this? Yeah.
call out one thing. I just started
Yeah.
closing polls. So before you leave, if you have to leave a few minutes early, please do answer our questions to let us know how we did.
Do you have a question in there about time management? Because I think it's going to be poor. Key thing here is that think of your text, number, date, time, and timestamp fields are always part of the bundle, and think of your container, summary, and calculation fields as when you see them. They don't always come along for the ride. You have to actually show them, reference them, include them in the screen in some way. some dependency or trigger has to be there to make them happen. So if you do show a container field, you're going to get the text, number, date, and time, and timestamp fields along with it. But if you show just those text and number fields, you'll just get that group of fields of that type, and you won't get these other fields, which often can be heavier and more expensive. So sometimes it's just about making sure you just don't show them by default. I'm going to keep rolling, Rosemary, and you'll interrupt me with important questions. All right. Tipping points. This is all what I was mentioning before, that there's things that like the user who asked about the finding that they see when they go to a particular layout. Sorting activity, summarizing activity, references across portals, predicate filtering. These are the kinds of things that can cause an avalanche of data, right? They can look beyond the prefetch and require significant volumes of data to be downloaded to evaluate that summary or that calculation or that filter. And even when the server is available to do some of it for you, which it may or may not be at that particular moment, it won't necessarily do all of it. We see it a lot in scripting where we, check for an unstored, are there any sales for this customer? And the way we ask for it, it has to look at all the sales for the customer. Or we have conditional formatting or portals, like I said, even privilege sets. If you're using privilege sets and using relations and unstored calculations in your privilege sets, you could be regularly asking the client to download lots of data to be able to evaluate whether you can do something or not. And so it's not even visible to you on your layouts, but it's buried into the underlying security framework of your solution. Knowing where this happens starts with understanding where it could happen just in simple layout mode. And then you can start to understand, am I doing the same thing in my script? Am I doing the same thing in my privilege sets and so on?
Yeah, there's a question, general question about what's the impact of narrow tables on reporting? Doesn't searching and sorting on related records slow things down?
So if you're searching on an index field, if you're searching on a normal field like a text or a number field across a relationship, it isn't necessarily going to be slower than searching on it if it was all in one table. That's not going to be really negatively impacted. If your report, for example, needs to use some of the fields that have been isolated, and you're going to bring in, it's still a one-to-one join, right, in those separated tables in those situations. So you're just separating them because of factors like we talked about before, busy, bigger, not always used. But there will be situations where you need to combine values from both or search across values from both. And that's not going to add a significant performance strain when you have to use them and combine them in those times on purpose. There's lots of things we could talk about in terms of reporting efficiency and how you might script and sequence how you assemble your report, and even how you might summarize data and store the summarizations of that data so that your reports can be faster. I think one of the presentations we'll share afterwards, I show a slide where 50,000 records to create a table versus 50 records to create a table, because there was a server-side script summarizing sales per month. And then I could run that report in 1.1 seconds as opposed to 15 or 20 seconds, because it only had to read the summaries. They were stored. It didn't have to read all the data. It's really nice to have dynamic data available to do your reporting, but there can also be benefits to summarizing data if it's relatively static after the fact, so that as your system gets bigger, you're reporting on a smaller set of data points. This slide was just coming back to the other one to show you examples of a couple tables that have a lot of records. And while these in themselves aren't bad, we've got tables and solutions with millions of records. It's like Greg was saying before, it's an area to kind of say, well, why is that table so big? And more importantly, are we making sure that we're really careful when we enter that territory in that table? Are we ever going to a report or a layout where there's summaries and unstored calculations or relationships that might be looking at thousands of records simultaneously? And we're going to pay for that. And can we somehow script or manage our layouts in a way that won't cause an avalanche and bring us a bunch of records we don't care about to get us the answers that we want? Or are these candidates for summarization? Are these reporting tables? Maybe that's sales, or maybe it's, line items on invoices or something, and we want to run reports on that. Well, at what point do those get big enough where we're getting thousands more records every time we run the report, and the report's getting slower and slower and slower as the years go on, as opposed to saying, you know what, this data doesn't change historically. Let's find a way to kind of collapse that into common reporting parameters and store that report data somewhere and then just run our reports there. So these are candidates for that when we see growing lists of records, especially in a table with maybe not as many in other tables.
Yeah, one of the things we see periodically is like an API log table that starts out nice and small, but it's got this big JSON payload field as part of that record. And over time, that might be tens or hundreds or thousands of records or millions of records, and that can get really, really big. And if that field has ever been searched on, so it has an index, that index has to get updated every time you make an API call, and all this stuff just stacks up and gets slower over time. So that might be a situation where you can prune those records or disable indexing on those big JSON fields and things like that to help improve performance.
All right, well, we have like 4 minutes left. So I think I have 2 requests. So one, there's a question that I think, Mark, you can answer really quickly. It would be nice to have a switch that prevents the summary fields from being calculated until I've searched for the records I need. How would you get around that without using a switch?
So as someone who doesn't develop as regularly as I did, my first thoughts would be, where am I doing the find versus when am I showing the summary field? Can I do the find in one context and then once I have the result, switch to the layout that has it? Or can I use some kind of hide condition on my summary field so I can reveal it when the time is right? And maybe when I've even tested how big my found set is, maybe I then prompt the user and say, you need to do a different find, that there's too many records here to summarize. But those are the 2 that come to mind really quickly.
Mark, the thing I thought you were going to say is entering find mode before you switch to a layout is really important. It's something you've been saying for years, and I think has a big impact in a situation like that where you're going to a layout that has summary fields on it, while that has all records. For instance, in the found set, enter find mode first, get the subset of records that you need, and then show those summary fields.
Right. And even a combination of those can be useful because you could still have a user who finds all, and now you're back to the same problem. But yeah, enter find mode, go to layout is very much different than go to layout, enter find mode. There's no prefetch, there's no summarization, nothing happens in find mode other than the layout loading. And the layout itself is just graphics and pretty lightweight.
All right, well, we are like down to 2 minutes. So
yep. I know we had some more slides with tips, and I'm more than happy to make this mini deck available, which is like a subset of the deck from Engaged.
Which I have already said I will share in the community later today because I've already downloaded it.
Okay.
So just, I think Angie put in chat, please join me in 2 weeks on August 7th. No, wait, today is August 7th. In 2 weeks on August 21st, Albert Haram Alvarez from Smallco will be joining me, and we're going to talk about ways to iterate rapidly in FileMaker and like make simple additions to your apps that really improve the user experience and increase ROI. So with that, I just wanted to also share, after this live stream, how confident are you in making changes to improve your app's performance? Almost 70% said confident or very confident. So thank you, good job. And I'm just going to share the word cloud of what's one improvement you are inspired to make. I see wide tables and schema. So I think
It's my favorite one. Thanks again for the opportunity, and I won't bother you guys with. You can find us at Skeleton Key and fill out a form or find my email address pretty easily in the community. We're more than happy to look over your shoulder, and I'll say I'm more than happy if you just want a quick consultation about what might be going on in your solution, point you in maybe the right direction where the usual suspects might be. Feel free to reach out. Be happy to help.
Yes. And I just want to acknowledge that we do have 2 seminars scheduled at the same time on the 21st. I will advise that the community live will be recorded and the other class will not be. So if you're wondering which one to attend, I would say go to the other one. But that one will also be repeated next month, I think. So anyway, thank you, Mark. Thank you, Greg. It was great to talk to you today, and hope to see you all in 2 weeks.